My name is John Webb. I'm the president of the Multi-Seal Corporation in Houston. Recently we've received a number of inquiries regarding the flammability characteristics of our sealant products, specifically our heavy-duty environmental formulation, which comprises over 90% of our fleet business in North America. They say that a picture is worth 1,000 words, and hopefully a short video will be worth even more than that. Today I would like to illustrate the flammability characteristics of our products using a propane torch flame. This is a relatively crude experiment, but I think it will serve well to illustrate the flammability characteristics of the products that will be encountered in the retreading process. This is not a polished presentation. The purpose of this presentation is to just illustrate some scientific characteristics of our products and the components that go into the manufacture of our products. As a matter of fact, our cameraman today is Al Brooks, our manager of tech service and manufacturing. So please bear with us in our backyard video, and hopefully we will be able to relay some important information to you. Today we have 3 products that will be flame tested. First is the heavy-duty environmental sealant, just as you would encounter in the retreading process as residue left in a casing. Of course, the main policy with the retread operation is to clean all products out of the tires, but in case something remains in the casing, this is what you would encounter. I'm also going to flame test the only combustible material that is used in the manufacture of our heavy-duty environmental sealant, and that is propylene glycol, which we will refer to as PG. Thirdly, we will be illustrating the flame characteristics of the fiber and filler residue that is left after the evaporation of a sample of our heavy-duty environmental formulation. So let's get on to flame testing. The sealant formulation itself consists of a mixture of 50% water and 50% propylene glycol as the liquid phase, and this is used to suspend the active ingredients in our product, which is comprised of synthetic fibers and inorganic fillers. Here we have a standard propane torch with a flame temperature probably greater than 1500 degrees. I will play this directly on the surface of the sealant. You can see that the sealant is beginning to char slightly. This is charring of the thickening agent, which is in at a very low treatment level, less than 1%, and charring of some of the fibers that we'll get into. You can see while it's steaming, there's absolutely no flaming of the sealant material. And remember that this temperature is over 1500 degrees. Now you can say, well, this is 50% water. Of course 50% water material isn't going to burn. So now let's take a look at the liquid phase of the sealant minus the water. As I mentioned, this is pure propylene glycol, and propylene glycol has a flash point of 228 degrees Fahrenheit, which means that under no circumstances will PG burn at less than that temperature. It has an auto-ignition temperature or kindling point of 699 degrees Fahrenheit. That means that no matter what temperature the bulk of the propylene glycol is, it must be exposed to an ignition source greater than 699 degrees. And of course, if there is an ignition source in the curing chamber that exceeds 699 degrees, it could also directly ignite other materials present in the chamber, such as envelopes and actually casings themselves. So let's take a look at how PG reacts to a 1500 degree flame. You can see steam, evaporating PG with no flames whatsoever. Now remember, we can force this to burn. It is combustible, but it must achieve its flash point and must be exposed to 699 degree ignition source. Now let's take a look at the dried residue left after the evaporation of heavy-duty environmental in a laboratory oven for almost 10 days. You can see the pad is comprised of fibers and fillers, and the little black specks are pieces of ground up tread rubber that we use to nucleate the plugs in wounds and tires. You can see it will not sustain flame, except that the tiny little patches of rubber will burn, but they burn for a second or two and then immediately extinguish themselves. This flammability characteristic comes from the fact that the fibers that are used in multi-seal heavy-duty environmental are para-aramid fibers, and these are kissing cousins to the fibers used in the manufacture of Nomex, flame-proof clothing. Very, very similar characteristics to Nomex. Will not sustain flame. So, this has been a very elementary and somewhat crude demonstration of the flammability characteristics of multi-seal products, but I certainly hope that it will illustrate the fact that even when exposed to extremely high temperatures, much higher temperatures than you would encounter in a curing chamber in the retreading process, the whole sealant, which is in all likelihood the product that would be encountered in casings, does not burn, and even the only combustible part of the formulation, propylene glycol, does not ignite even after repeated exposure to the extremely high temperature of the propane flame. And to cover all of our bases, we have illustrated that even dried residue of sealant will not support any sort of combustion due to the fact that it is made out of aramid fibers which don't burn. Instead, they carbonify and leave just a carbon skeleton of the fiber structure itself. I would encourage anybody, any doubting Thomas, somebody that would like to see this for themselves, to conduct these experiments with a sample of our sealant in their own location, to be 100% convinced that the flammability characteristics of multi-seal sealant products are not participating in the incidence of any sort of fires incurred in curing chambers. Thank you very much for your time, and I would be happy to answer any questions that might exist in this topic.